Hello and welcome. On this first video, Introduction of Motions, we will talk in details about the different types of motion of JAKA robots. Let's start. Let's first have a look on the general content of this course. First we will talk about linear motion, then joint motion, relative linear motion, and we will end with circular motion. The lecture time should be around 16 minutes, and we have two objectives: understand the motion commands and know about the singularity. Let's start. First one, the linear motion instruction. First, we will have a look on a linear motion in a simulation software. We can see that the trajectory of linear motion is a straight line. This is the first feature of linear motion. Second, we record the linear motion of the robot and tool in the Cartesian coordinate. That is the values of x, y, z, rx, ry, rz. At last, the linear motion will involve an inverse solution calculation, so there will be singularities in linear motion. The JAKA robot has three singular points and positions. The first one is the shoulder joint singular point. The intersection of the 5 and 6 axes of the joint lies in the plane formed by the 1 and 2 axes. The second is the singular point of the elbow. The 2, 3 and 4 joints of the robot are coplanar. That is, robot big arm and forearm are almost collinear. The third singularity position is when the joints are parallel to the 4 or 6 joint. Now take another look at the programming instructions for linear motion. Click on the function to open an editing interface. In there, we can first modify the name of our point, that is a remark information of this point. Second, we can go to set a speed and acceleration. The recommended acceleration is below 1000 mm per square second. The third attribute is to stop or arc transition at this point. Fourth, the instruction skipping condition. When a state set by stop condition is made, our robot will skip this instruction. The fifth one is to edit a point of our machine movement. Click on Editing Interface, and it will jump out of the picture on the right, which is interface for teaching the robot. After the teaching is completed, click OK, and then return to our previous interface, click OK again. And then our motion instruction is edited. Now watch the actual linear motion. In our programming software, we can start to set the first point. This is our second point. And then we can teach the third position. We see that we have set 3 points in the program, and then the robot will add a loop, and the robot will walk a triangle between these 3 points. At this time, let's modify the second point. We will add an arc transition to the second point with an attribute of 50 mm. Save our program and then run it again to see the effect on the machine movement. Okay, we saw in the video that the robot did not accurately reach the position of the second point, but made a transition through an arc. We need to pay attention to some things when executing motion instruction. Because our linear motion records on Cartesian coordinates, when we modify our tool coordinates or system coordinates in the program, the point of the linear motion will also change accordingly. Then, the joint motion instructions. As previous, let's look the trajectory of the robot and into the simulation software. We can see in the video that when the robot moves through joints, the trajectory of the end tool is an arc. This is the first characteristic of joint motion. Second, our joint motion records the angles of the 6 joints. Let's take a look at programming instructions for joint motion. As previous, we can see all the action we can do for joint motion. But different from linear motion, the speed and acceleration of joint motion refer to the joint's movement. The recommended acceleration of a joint motion during programming is below 400 degrees per square second. Our joint motion uses 6 joint degrees, so when you modify the user coordinate system or TCP in the program, the motion position will not be changed. For edit, it will be the same action as previous for linear motion. Let's take a look at the actual running effect of the joint motion in the program. After the teaching is completed, we can run our program. We will see that the robots make a move to the 4th point taught by it in a joint motion. Relative linear motion. When you click on our relative linear motion, it will jump to this interface. As previous, you can set names for these positions. Next, there is a choice of reference coordinate system. Here we can choose the user coordinate system or the tool coordinate system. The choice of the reference system will determine the direction of our relative linear motion. Then you can also set the relative value of speed and acceleration, because the speed and acceleration of the motion are the same as our linear motion. As always, you can choose to stop at these points or add an arc transmission. At last, you can enter the value of the linear motion where the robot will move accordingly to the current position. Okay, now let's take a look at the motion effect on relative linear motion. First of all, we need to set our initial position. Then edit the properties of our relative linear motion. Here, our second motion command is 300 mm in the Y direction, and the third is 300 mm in the X direction. Then the fourth Y direction is minus 300 mm. Here we choose our user coordinate system in the properties of our relative linear motion. So we did not set our coordinate system in our program. The default is to do a relative linear motion under a world coordinate system. The end of the robot is 300 by 300 square. At last, let's see the circular motion. First, click on the arc motion to start the arc motion editing interface. In this interface, we can set the speed and acceleration of our arc motion. The speed and acceleration here also refer to the TCP at our robot's end. Then the second one can be edited to choose to stop at this point or arc transition as we saw previously. Then the third is to set one of our passing points. That is to say the middle point of our arc movement and our end point. Click one of our icon 1 or 2 and then it will jump to our robot teaching interface. Let's try teaching our robot's position and then click OK to return to an interface of our arc motion editing. Fourth, the number of motion circles. If the number of motion circles remains 0, the robot will perform a 3-point motion, corresponds to a semicircle. In point 1 to let the robot perform a full circle motion. Look at the motion effect of our arc transition and its programming. First, you need to teach the starting point of the robot. This will be the first point of our arc motion and also the current position of the arc. Then you need to teach the point in the middle and the point at the end. For that, you need to click on 1 and 2. It will jump into the teaching robot interface. When it's done, we can run the program. We saw that our robot made a 3-point arc motion. Now let's modify our program and set a full circle motion. Now, let's change it to 2 circles. So we saw that after 2 arc moves, there will be a pause on 1 second. Now let's modify the number of circles and put 0.25 circle. The robot made a quarter of a circle. This concludes the content of this section. Thank you for attention.